Hello, welcome to the lecture for Chapter 2 on scientific methods. Now, I'm not going to play these videos for you, but I do encourage you to go ahead and do a YouTube search for the Asch experiment, the Milgram experiment, and the Gottman research, because it really does show you, it brings to life what can be rather dry material of what does research in psychology look like. The Asch experiment, you'll be able to find a brief video where it had to do with lack of a better word, peer pressure or conformity in a line experiment. The Milgram has to do with listening to authority figures despite your own inner conscience. And the Gottman research has to do with being able to predict divorce with over 90% success rate sort of thing, just by observing couples in challenging situations. So take a moment, do a YouTube search, and watch a few of these experiments. So here's an outline for our chapter. Section 1 is the scientific method and behavior. Section 2, we dive right into those research methods. And then Section 3 is the statistical methods for research. So what is the purpose of psychological research? Well, you should have a question, right? I mean, we're human. We should be curious about why people do the things that they do. And then the question should be grounded in theories. And we went briefly over the theories in the lecture on Chapter 1, right? We're going to really go into those theories in future chapters. And based on this general question, you should develop a hypothesis. And a hypothesis must be an if-then statement. If this, then that sort of thing. And then based upon that hypothesis, you come up with very specific predictions of what you expect to see. Then you go into the methodology. The methodology should be driven by the question, right? And then you analyze your results, and then either you support or you do not support your hypotheses, and then you move on. And a lot of times people who they do these research studies and they don't support their hypotheses, it's hard to get those results published in the research journals because everyone wants to have, significant findings sorts of things. But it's just as important if the hypothesis isn't supported. That's important to know too of, oh, this didn't work out. I want to take a moment to distinguish between valid versus reliable, validity versus reliability. A valid result or means of measurement means that you're actually assessing what you think you're assessing. So, for example, if you're interested in stress, what is a valid way of measuring stress? Do you want to do a self-report survey? Do you want to be looking at heart rate and perspiration or blood pressure? But you want to make sure that however you're choosing to measure this, whatever your variable is of interest, that you're validly measuring it, that you're really measuring what you think you're measuring. Reliable means that you get the same result over and over and over again. So, if there's these big groundbreaking studies, well, can you repeat that? Can you find it over and over again? Can you find it in different populations or different age groups? How reliable are these findings? So reliable, kind of like having a good, reliable friend. They're there when you need them. Reliable in research means you'll get the same result every time. And that goes into the importance of replication, that these studies, it's not enough to find it one time. You need to replicate it. Whoops, I apologize. So I apologize, that was my phone ringing, and rather than go back and re-record everything I recorded, we're just going to move to the next slide where I will address applied versus basic research. And so applied research is when you're trying to solve an actual problem. Okay, so let's say you're interested in workplace environments. What amount of light is too much light and overstimulating versus what is too dim of light to allow for productivity? So you're trying to address a specific problem. Whereas basic research is you're just really curious about something. And down the road, that research may or may not be able to be applied to a real life problem. Okay, so Section 2, research methods. Okay, so why do you want to study people? And so the question that you have is going to, again, dictate the approach that you take. So if you're just wanting to describe something, so for example, who shows more aggressiveness on the playground with children? Is it boys or girls? Then you could do an observational study. And so you're not controlling anything. You're just saying, hey, I'm just going to observe this happening in the real world and what kinds of patterns emerge. And so you could do that naturalistically. You could just go to a playground and observe the kids that are there. You could do it slightly more controlled to where you have a lab setting. So big universities that have big psychology programs, they have, homes that are set up to, well, they look like homes, but they're actually study places. They're labs with one-way mirrors to just observe people and, in very natural sorts of situations. And so some of these programs have playgrounds to where they have a little bit more control. So they're inviting the children, they can choose certain age groups, right? But then at the end of the day, they're still observing. And then the third one here is a case study. There are many things we're curious about in psychology that you could never do in an experimental sort of way. For example, there's the case study of Jeannie. It's a true story. You can look at the documentary up on YouTube. She had been tied to a potty chair the first 12 or so years of her life, and if she ever made any sounds, she was beaten. When she was finally rescued, she had absolutely no language ability at all. And so they were studying her to see, okay, can we help her develop language ability? Can we get her to native fluency? And what they learned from the study and from other cases like her is there does seem to be a very sensitive period that if you don't master a first language by puberty, you will never have native fluency. There will be aspects of language that you will never be able to master. So again, you would never do an experimental study where you say, okay, here's 100 babies. Half of them, we're not going to allow them to have any language. Half of them will be normal language exposure and see what happens. That would be completely unethical and impractical. But when we have these case studies that pop up, we can use them to try to draw general conclusions regarding things we're curious about. Okay, so that's describing. Let's say you want to predict, though, that if I have X, then I will likely have Y. And so that would be a correlation. Now, correlation does not imply causation. You can't say for sure just because I have one, it's causing the other. And our brain likes to work that way. We like to say, one thing is causing the other. But sometimes you just can't do that, okay? And so that's where we get into correlations. So there's more than three, but the three we're going to cover is a positive correlation, a negative correlation, and curvilinear. For example, for a positive correlation, both variables are going in the same direction. So if you study and for hours and hours, the more hours you study, the greater your exam score should be, right? That would be a positive correlation. However, we can't for sure say that the number of hours that you're studying causes the test score to increase, because there's other factors. Maybe you had prior knowledge, maybe you have higher intelligence, or there's any number of factors that can also intervene in terms of hours of studying and ultimate test score. Now, a negative correlation is when the variables are going in different directions. So as one increases, the other is decreasing. So for example, the amount of exercise and body weight. So typically, as exercise increases, body weight tends to decrease. And so that would be an example of a negative correlation. Curvilinear is interesting because the variables will increase together to a certain point, and then one will start to increase and the other will start to decrease. So for example, stress and performance. To a certain degree, you need a little bit of stress to motivate you to study, sort of thing, or to do whatever it is you're stressed about. But then if you reach a high level of stress, it's going to start to impede performance. And so that would be an example of a curvilinear relationship. But again, I just want to drive back, correlation is not causation. So for example, both ice cream sales and drowning incidents increase in the summer, but you would never say that one is causing the other, sort of thing. So that's kind of like one thing to keep in mind. Okay, now the coefficient. The coefficient is what is a statistical thing that explains the strength of the relationship. So if there's absolutely no relationship between two things, such as drownings and ice cream sales, then it would be a 0. Then it goes all the way to either a +1 or a -1, and it's the absolute value. So a -1 correlation is exactly as strong as a +1 correlation. The difference is the +1 is a positive correlation, whereas the -1 is a negative correlation. So the closer that you get to either -1 or +1, the stronger the relationship is between the two, the stronger you're able to predict one from the other one. Okay, so then here we're going into explaining. So when we are wanting to be able to say one thing is causing the other, then we have two options. Now, to truly say one thing causes the other, you have to do experimental research, and I'll explain that in a minute. However, there's a lot of things in psychology that we can't do a true experimental research. For example, maybe we want to know the effect of divorce on children. We can't take a group of families and say, half of you have to divorce and half of you have to stay married no matter what, and then study the effects on the children. You can't do that. So you have to take the pre-existing groups. So you're not controlling who's in what group. You're saying, okay, these children, their parents divorced, these children, their parents stayed married. What is the difference between these two groups in terms of mental health outcomes? So that's what differential research is. It's where you're taking pre-existing groups and comparing their outcomes for whatever it is you're interested in. With experimental research, however, you have absolute control over who is in what group. So, for example, maybe you're interested in investigating the effect of sleep deprivation on cognitive performance. And so here you get a group of people and you randomly assign them into this, you're going to be sleep deprived or you're going to have a full night of sleep sort of thing. And so you have control there. And so that the term there, random, that's why it's very important that for true experimental research, any person that you pick to be in your study or volunteers for the study, they have an equal chance of being assigned to either of those two groups, right? Now, then you would measure, so the independent variable is what you're controlling, sleeping or not sleeping, and the dependent variable is dependent upon that independent variable, their cognitive performance, and however you want to measure that would be up to you, okay? So the independent variable you control, the dependent variable you do not control. It's the outcome based upon whatever it is that you did control, whatever you manipulated. Okay, and then the representative samples. So let's say you're interested in sleep deprivation for college students, okay, and their performance on an exam. Well, let's say at FSCJ, we know how many different age groups are there. We know different ethnicities. And so we want to make sure that the people we have coming to our study represents what our student body looks like, that it kind of breaks down by demographic groups the same way that we would see in the population at large. Because if you're going to, generalize the results of your study to all FSCJ students, well, the people in your study better look like what the FSCJ students look like. They should be representative of what the college in general looks like. Okay, so we are almost done with this slide. We just have a few other issues to discuss. So experimenter bias occurs when the researcher's expectations or beliefs unintentionally influence the results of a study. And this can happen in various ways, such as through subtle cues or body language that may affect the participant's behavior, or through biased data collection or interpretations. So for an example, a researcher who strongly believes that a new drug will improve memory might unintentionally give more positive feedback to participants in the experimental group, which could influence their performance or responses. Okay, below that is participant bias. And participant bias occurs when participants in a study behave in a way that they think the researcher expects, or in a way that they believe will make them appear more favorably. And this can skew the results of a study. So, for example, if a participant knows that they are being observed in a study on social behavior, they might act more socially desirable than they would in a natural setting, leading to results that do not accurately reflect their true behavior. One way around this, though, for example, I mentioned how big universities have houses with one-way mirrors to be able to observe people. Pretty much, if you think of reality TV, if you give it enough time, people will resort to the way that they would behave normally, sort of thing. They'll forget that they're being observed and show their true behaviors. Okay, so this, time would be a part of that. Okay, and then finally, the double-blind study. A double-blind study is a type of experimental design in which neither the participants nor the experimenters know who is receiving the treatment and who is receiving the placebo. And this is used to prevent both the experimenter having bias and the participant having bias that would affect the results. So, for example, in a clinical trial testing the effectiveness of, say, a new antidepressant drug, neither the participants nor the researchers would know who's receiving the actual drug and who's receiving the placebo, or, like the sugar pill sort of thing. And this helps ensure that any differences in the outcome are actually due to the drug itself rather than expectations or biases from other side. So the placebo effect is a real thing, that if a person thinks they're getting a medicine, there will be this placebo effect of, oh, I feel much better sort of thing. And so if you're in a double-blind study, it can kind of try to negate that possibility. Okay, ethics. So hopefully before you got into this PowerPoint, you went on a YouTube search and you found out about Milgram. Now I want you to take a pause and look up Zimbardo and the Stanford prison study, okay? Because that really shows you how ethics, there's been some landmark experiments in psychology that were completely unethical and would never be reported or repeated today in America. So because of experiments like Milgram and Zimbardo's Stanford prison study, we now have what's called an Institutional Review Board, or IRB. And what this is if any psychologist at a university wants to do a study, you have to fill out a whole bunch of paperwork, and you have to submit it to the IRB for review. And the IRB consists of other professors, some administrators, and community members, so that everybody can look at this and say, okay, this study will do more good than bad, won't cause any serious harm, or hey, I don't think this is a good study for you to do. Part of the IRB process is writing an informed consent form so that the participants in the study, one, have a general idea of what the study is going to be about, know any potential risks, and so they can, and know that they can stop the study at any time without any sort of, harm coming to them. And so that way they're consenting to be in the research from an informed perspective. They know what to expect. Deception needs to be kept to a minimum. So like we learned on the previous slide, there can be this participant bias sort of thing if they know what you're studying, like social behavior. So you can be kind of vague of, oh, this research study is looking at that. And then after the fact, you have to go back after the experiment's over and say, I told you it was a study in social psychology. I was specifically looking at whatever it is you were looking at. And then you have to offer to share your study results with them once everything is done. Also part of the IRB is that everyone must be kept anonymous, sort of thing, so that the consent forms are separated from whatever their results are, so that one thing can't be connected to the other. There has to be this sense of anonymity and confidentiality. I guess confidentiality is the better word. And then also there's some groups that are considered more vulnerable. So if you're wanting to study children, it would have to be the legal guardians who are assenting to this. You still want to explain to the child, but they can't make an informed consent. It has to be their legal guardian. Those who have mental disturbances, mental illness, or are intellectually challenged, they're going to need somebody to say, okay, I think it's okay for them to participate in this study. And prison populations are considered to be also a vulnerable population for research. Okay, and then again, the benefits of the potential study must outweigh any potential cost. So take a moment here before we move on and think to yourself, okay, what's the purpose of descriptive research, of correlational research, and experimental research? And then we have differential research because it's awfully hard sometimes to use true experimental research for the things we're curious about in psychology. Section 3, statistical methods for research. Okay, so what are statistics? Statistics are mathematical methods that allow us to use data to describe and interpret the results of our study. And there's two major classes of statistics important for psychology. There are descriptive statistics, and here's you're again describing who your people are. So what was their average age? What was the breakdown between males and females or different ethnic groups? And so we're looking at mean, which is the average, the median, which would be the middle number, or the mode most frequently occurring number. And then measures of variability such as range and standard deviation kind of gives a breakdown of how are those scores distributed. Okay, and then there's the inferential statistics, and this is where we're trying to actually draw conclusions based on our research. So an operational definition specifies how a concept or a variable is measured or manipulated in a study, and so it's translating abstract psychological concepts into very specific measurable terms that can be consistently used during research. So going back to stress, if a researcher is studying stress, they need to define how stress will be measured in their study, and so an operational definition might involve using a specific questionnaire, such as the perceived stress scale, where participants rate their stress levels, or it could be something more, hard science, I guess we'll say, such as measuring cortisol levels in the body as the indicator of stress. So at the end of the day, the operational definition ensures that other researchers can replicate the study because they know specifically the criteria used to measure your variables of interest. Now, statistical significance is determining whether the results of the study are likely due to just random chance or a real effect going on. And so, for an example, in a study testing whether a new therapy reduces anxiety, the researchers could find that the therapy group shows a greater reduction in anxiety levels compared to the control group. And it gets into a lot of statistics, which we're not going to worry about too much in general psychology, but there's something called a p-value that will let you know, oh, this could have been due to chance and just randomness, or hey, this actually had an effect. Okay, so take a moment, think to yourself, why do psychologists use statistics? And what's the difference between descriptive and inferential statistics? Okay, so this is if we were in class, so we don't have to worry